Devi.
Trisha.
No, Sai Shivam.
Sai. Okay. Fine. Yeah, the other one. You are on mute, I guess, Trisha.
I'm also from DB.
DB. Fine. Okay. Fine. We'll start. Okay. Myself, Girish. Okay. I'll be taking your mock today. So let's begin with Sai. Tell me about yourself, Sai.
My name is Sai Shivam. I am from Andhra Pradesh. I did my BE in Electronics and Communication from KLE College, Belagavi. Currently doing my Masters from VIT Weldur in VLSI Design. As a part of my MTech, I am doing my internship at Intel from past 6 months.
Okay. When did you completed your engineering?
2020.
2020. Okay. So what was your BE project?
Mini project I did on ITC protocol.
B project.
B project.
project.
Okay. B project is some odd. It's like automation, means not did properly.
You didn't do a project.
No, I did it. It's an name. 1 second. I'll just declare that. Automatic vehicle means autonomous vehicle for industrial application.
Autonomous vehicle for industrial application. So your area of project was on automation, or was it on IoT, or anything with the automation side?
Only on automation.
Only automation. So what was your main aim of your project? What was the main aim of your project was like?
It was like to control means a car without any means human intervention. Okay. Sorry. So means in that we programmed Arduino in such a way that it will no, actually not Arduino, it's Raspberry Pi. We programmed Raspberry Pi and included a Pi camera, and it will detect the sign, road sign like right, left, stop, and go. And it will follow the lane and it will move.
So you programmed your microcontroller to make your vehicle operate, right?
Yes.
So you have you used any kind of cameras in your application, or what was it used to take as a data? From where was the data being captured?
Initial data is given to the means program, that symbols are given to the program, so that the camera will capture the signals, and according to it will work.
Fine. Okay, Trisha, tell me about yourself.
Hi, I'm Trisha Sharma. I'm from Bilaspur, Chhattisgarh, and I have completed my BTech in Electrical and Electronics from VIT. And after that, I have attended VLSI training from Maven Silicon, and recently I'm doing an internship in VLSI FOR ALL.
Okay. So what was your B project?
My project was inverted pendulum.
Hold on. Sai, you can mute till I ask you, because I'm getting too much noise from your end.
Okay.
So basically my project...
Hold on. Trisha, you mute me. You mute yourself. Hold on for a second.
Which was to balance a stick in an inverted position in 90 degrees. This technique is basically used in rocket propulsion techniques and in self-balancing robots also.
Okay. So what was the area of your project? Like what techniques or what principles did you use in your project?
It was actually a mechatronics-based project, and for that we have used one angle sensor, gyroscope, and I controlled the motor. Basically, we need to oscillate the base so that the pendulum should be kept in inverted position. So for that we have used a stepper motor, and to control that stepper motor, we have used an Arduino. So basically we took the input from the angle sensor, and we monitored it using the Arduino. And according to the changing angles, we changed the stepper motor directions.
Right. So you somewhere worked in the IIT area or embedded area on your project, right?
Yeah.
Categorize it to IIT or IoT or embedded?
IoT.
Okay, fine. So your password batch is?
2021.
21. Okay. And yeah, you used Arduino, right?
Yeah.
So which was it?
Uno.
Uno. Okay. So what's the Arduino Uno architecture? I would say, like, how much bit architecture is Arduino Uno?
As far as I remember, there are 8 input-output pins, GPIO pins.
Architecture. How many bit architecture it was?
It was a 2-bit architecture.
Huh?
Sorry, I don't remember it.
Shiva, do you know anything about this? Arduino Uno, how many bit architecture it is?
And I'm not sure, maybe 16-bit.
No, fine. Okay, fine. We'll move to the topics. So, Shiva,
Yes, sir.
what are your best areas in electronics and communication?
Digital electronics,
Okay,
network theory.
okay.
And remember those two, means meaning I'm not touching.
Okay, Trisha, you?
Mine is digital electronics.
Okay, fine. We'll begin with digital electronics. Okay. First question for you, Shiva.
Yes, sir.
What do you mean by a gate?
Gate. Gate is a structure, means it is formed by using transistors or MOSFETs for the operation, means like ANDing or
Trisha.
So gate is basically a searching device which provide the output based on the combination of inputs.
So wire can be also a gate, right?
We can't control a wire.
No, you said that it provides the output based upon the input.
Yeah,
Even wire provides the same output based upon the input you are giving. If you are switching it to the 0, then it will give 0. If you're switching it to 1, it will give 1. What's the difference between a gate and a wire?
In gate, we can also call a wire as a buffer circuit, because whatever input we will give, the output will follow the input. But in gate, depending on the combination of inputs, it will provide the outputs. Means, for example, let's suppose an AND gate. If we provide 1 and 0, then we will get 0, or if we provide 1 1, then we will get 1.
So what do you call this whole thing, providing 1 1 and getting 1 output?
Controlled in
giving combination.
No, see, she said that if you give 1 to wire, you get 1 not the output.
Yes, yes.
She said some combination. If you provide some combination, you get some output. This is what she said.
Yes, yes.
So what do you do? What do you call this thing? Providing a combination of input and getting a output.
No,
if you are getting output as 1
yes,
by providing 1 1 as input.
Yes.
So why? How does it give you 1 only? Why doesn't it give 0?
It is I think parallel combination.
Sure.
Performing operations on inputs.
Simple. The gate is a block which takes inputs and gives output based upon the logical operation.
Yeah.
Right?
Yes.
The main thing of the gate is logical operation.
Okay.
To perform a logical operation, right? And, or, not, NAND, NOR, XOR, XNOR, all has some logic. So you have to specifically mention that it's a logical operation. Okay.
Okay.
Fine. Next question for you, Trisha. What do you mean by flip flop?
Flip-flop is a storing element which stores the data and provides
Stores the
it.
data. So what do you mean by a latch then?
Latch is similar to flip-flop. It also stores it is also one bit memory storage element, but the basic difference between latch and flip-flop is that latch is a level sensitive device, whereas flip-flop is edge sensitive device.
So can you explain me how does a flip flop store one bit data in itself using waveforms or using the circuit? You
Yeah.
can share the screen. There are three dots right on your
Yeah.
system. Yeah, you can press there and you will get a whiteboard there. Okay. Once when you open your whiteboard, you have that screen share option present now. Press on that and press as a tab and select your tab. Okay. Who's the new entry here? Please speak out.
Yeah, hello sir, this is Nayana.
Okay, turn on your camera.
Yeah,
Yeah, fine. Till Trisha, you continue to set up yourself. I'll take some questions to Naina. Okay. So Naina, are
yeah.
you ready to take up the map now?
Yes, sir.
Okay, fine. Uh, so tell me about yourself, Naina.
Yeah, hi. My name is Nayana. I have done my MTech recently from Dr. Ambedkar Institute of Technology in VLSI Design and Embedded Systems with around 9 CGPA. Like, and also, I have done my BTech in JC Engineering College, Mysuru in instrumentation background. I'm also taking training in design and verification from the VLSI for all. Currently, I'm actively looking for the jobs in the VLSI field. Uh, yeah, that's it.
You have to conclude. If you keep quiet, how can I get to know that you have something more left to speak, or is it an end? Okay.
Yeah, that's it.
Just hang on for a second. Sorry for the interruption. Yeah. Sorry. Yeah. And you, when did you complete your BE?
B in 2020, MTech in 2022.
20 and 2022. So, what about your BE project?
Yeah, I have done my B projects on like Arduino.
Mm,
Yeah, like it was a seed sowing robot. Like we have developed a robot which can sow the seeds in the playground with
mm.
some mechanical extension, and we were using the funnel and all, and to store the seeds and all, like, and we use the mainly Arduino board with a Bluetooth connection. We use that, we monitored that Bluetooth connection via phone. Using the phone itself, we monitored that robot to go front and back, like left and right.
So, what was your Bluetooth version used?
Yeah, that was. Sorry, I don't remember about that. Uh,
Okay. So, you used Arduino, right?
yeah, Arduino at
What
Meg.
was it?
Sorry, can you repeat?
Yeah, yeah. Continue. You said something at Meg something.
Yeah, there we have a microprocessor called Atmega 328 in that.
Microprocessor. You sure about that?
No, sorry, microcontroller. It's a
Mhm.
microcontroller. Yeah, we used, by using the C language, we coded that.
Okay. So, how many bit architecture was at Meg using?
Actually, no, sorry, I don't have any that much right now knowledge about engineering project. I can explain a MTech project.
So what was your MTech project?
Yeah, basically my MTech project was it's a FPGA based vending machine. It was basically designed using the FSM, Mille FSM to be precise. Like in that, we have seen many vending machines which vents out the beverages and like that. It was a vending machine which vents out the logical gates. Like AND gate, OR gate, it will be vending out that. Like I have a using the Verilog, I have used the Xilinx for the simulation and the synthesis. Like using that Xilinx, I have used Arctic 7 FPGA board. Like there, I had 8 inputs. I had given the 8 inputs by like I have given the inputs with the binary encoding.
Okay.
From
It's enough. Fine. So are you trained at looking for the jobs in DV or trained in DV?
Yes,
Okay.
I'm looking for a job in
What are your
engineering.
areas? Good areas in electronics.
Yeah, digital electronics
Hmm.
and also Verilog, system Verilog UVM.
Fine. Fine. I will be continued with the same questions which I am throwing at Trisha and Sai right now. Okay. So what do you mean by a gate?
Yeah, basically gate is a very basic component which is very basic. It makes up any circuit.
So even flip flop makes up a circuit.
No, there are some several gates. It works on some basic logical, like AND gate means it has its own set of inputs, and for that it has its own set of outputs. Like it works on its own logical.
Same thing works with the flip flop. For T flip flop, for D flip flop, for SR flip flop. They
Yeah, but
have
in
different set of
flip-flop,
inputs.
we will be having a memory, like it can store a bit, but gates doesn't store any bits.
Okay, apart from that, what's the other difference you can say with the gate and flip flop?
And also like in gates we have universal gates. Using that universal gate, we can.
No, no, just see, Naina.
Uh,
Just asking you to define a gate just for 1 mark.
okay. In gates we don't need to give any clock.
No, I'm asking you define a gate. You don't need to explain. Just define it.
It's a combinational circuit.
Okay. Is that enough for the gate?
Yeah, it will be having its own logical to work, like AND gate, OR gate, XOR gate.
That's it. That's it. It's a block which works with the logic,
Yeah,
provided that you are giving certain inputs to get a particular output.
yeah.
Fine. Okay. Trisha, yeah, you explain me that. You can present that. There's a option to present your screen and present the tab which you are going to explain. You can explain using waveform, circuit, anything, but you have to explain how does a flip-flop store a single bit.
Is it visible? The screen?
No, 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 no. See,
No.
yeah, now it's visible.
Yeah. So I'm using a flip-flop screen.
Okay.
So this is my clock, and this is the D input. So this is a positive edge triggered flip flop. So whenever I will get a positive edge of the clock, then only the D input, the output will follow the D input. So we can see here I am getting a positive edge, and at that time D input is high. So on output we are getting the high output, and we'll get the high output until the next edge comes. In between, even if the D input changes, for example, we can see here. Here it is triggered in the second edge. The input is triggered, and therefore the output is following the D input. In between, the D input changed to a negative value, but still it is following the positive value because it is a edge triggered circuit.
Okay. You have made some mistake here. If you can rectify, then fine. If not, then I'll give this chance to other two. What's the main purpose of D flip flop? What do you call a D flip flop? What does a D flip flop do? What's the D flip flop logic is? If I can't mention it as a logic.
Output follows the D. Means D. Yeah, output follows the D.
That's okay, but how does it follow? See, you are a verification engineer, right? So there in a circuit there will be a flip flop or a block somewhere which is having some input, but you are getting an output something wrongly. Like for example, if you are giving at 10 nanosecond the D input, you are and expecting the output at 10 nanosecond to be a logic high, but you are getting a logic low input at that moment. So is your block working correctly or not?
No, we need to provide a delay.
How do you provide a delay?
Means immediately the output will not change. It will take some time.
Okay, so what do you call that?
Propagation delay.
Okay, so propagation delay of what?
No, it's a clock to Q delay.
If it goes to be a clock to Q delay, what do you call that clock to Q delay as?
Flip flop delay.
No. Sai,
Hello?
you heard everything, right?
Yes.
Yeah. Tell me what's the mistake she has done and what needs to be rectified to do, or what needs to be corrected. Even Nayana, you have an eye on this.
Actually, the third positive edge, like as we know, D flip flop input should be followed at the output. In third positive delay, the D input is low, so output should also be low.
I'll give an hint to all of you. The mistake lies between the first, second positive edge itself. There is no need to go to the third, fourth.
Clock toggles between 0 and 1, and is that something?
What do you comment on this, Trisha? He said something. Sai said something.
No, I didn't.
Repeat.
Clock
Actually, clock should toggle between 0 and 1. It is going negative value.
Oh, okay.
That line
Going below
indicates
the
0, right?
Okay, that's one mistake. What's the other one? Trisha, have been we can easily notice that you are opening multiple tabs to answer the questions.
No, it was opened earlier. Sorry, it was opened earlier.
No. See, this is a mock interview. Fine, that's okay. Be careful when you're doing this in an actual interview. Okay, that too online. Because they trust that. No, I'll give you a comment on this. Because they trust you that you won't cheat and they will schedule an online interview. And if they found this thing, even though if you do however good, they are not going to accept you. Okay, make sure that you have only one tab. That's your Google Meet. Okay, fine. Naina, have any comments on the mistake what she has done? Sai, Shiva.
Maybe the starting point is not clear.
Which starting point? Where?
Like the clock is starting and the D input is starting.
That's not the mistake. You explain the concept, Trisha. I'll explain the mistake later. Explain how does it store.
As I said, it stores the elements only at the positive edge. So at the positive edge, whatever is the D input, the output will follow that same input. So even if in between the edges, the input changes, then also it will retain the past input. And yeah.
See, when you stop sharing, I'll share a screen here. Okay.
Some skew will be there.
No. Hold on. I'll share and I'll ask questions on that only. Can you see this? Can you see my screen?
Yes.
Assume this as a clock. Okay. Clock. Something. This was like this, right? Yours was like this, right? D input, right? This is output, right? Tisha, if I'm making any mistake in replicating your whatever the drawing, let me know, okay? Like this, something beautiful, something like this, or no. See, the first thing is D means we can call it as two things. D means the first is delay, okay? Delay flip-flop, okay? Second thing is data flip-flop. So what does it do? It delays and sends the data. It doesn't change anything, okay? The first thing is, so it's delays. So when whatever the output you are getting at this input, this positive edge will be from the past input. Means, see, at this positive edge, the D is 1. So where you will get 1, it will not get at the immediate time. Immediate clock edge, you won't get it. Will be given at the second here. At the second clock edge, it will be outputted. So the output will be like this. Okay. At the second output, if for example, if it is like this, okay. So till here you don't know the input, so you should not write anything. Output. I'm saying sorry. You should not write anything here. Okay. You have to begin your output from here, because whatever the input, as you said, the output follows the input. The input is high when the positive edge is there. Okay. At the positive edge, if it's a positive edge triggered flip flop, the output will follows the input which is at this time. So it is 1 here. So that 1 will be coming out at the second edge. Okay. And the whatever the input at the second edge will be given at the third edge. So that follows at the third edge. That will be outputted. So what happened here? It is taking this one complete cycle, right, to output. So what's happening? It is staying the same. The output is staying same for this one cycle, right? So what happened? This data is stored for this one cycle. Means it's one complete cycle of storing. So data is stable. So this one cycle is completely having signal 1. Even though if the input changes, it won't change for that particular time till the next active edge is appearing. So when the next active edge appears, it will go low. Okay, it will take this input, it will go low. Understood? So this is how your element is stored. Got it? Okay. So now I'll pick questions from here only. I need to share the screen. So you have this, right? Now tell me, this one clock period, you have the right, this one period, what's going to happen in this one period of time? Sai,
Yes, sir.
what's going to happen in that one period of time? Oh, sorry.
Which one period can you show the screen?
Whatever the time here, this in the output, when the output is there, from this
Okay.
clock edge to this clock edge,
Okay.
this one period of time is there, right? One time
Yes,
period
yes.
is there.
Yes, yes.
So what's going to happen in the circuit when this time period is happening? When this during this time period?
Circuit. It will hold the value.
It will.
Hold that value one.
How would you say that it will hold the value?
Because of NAND or NOT gate internal structure feedback.
You don't know the internal circuitry. Assume you don't know the internal circuitry. So what's going to be inside? What's generally what is going to happen inside that time period?
Okay. It won't check for the any inputs because it checks at every posit, right? So posit to posit, it don't check. It don't take any input. So the one will be constant.
Okay, that's one point. What's the other points?
It just remain in that state.
Yeah, that remains. I'm asking about the internal thing. What's going to happen? Heard about setup?
Yes.
Yeah, setup time.
Heard about period?
Yes.
You calculate a skew, right? While calculating, you have a period, right?
Yes, whole time.
So where do you get that period? The period
Like-
duration, how do you calculate it?
Like minimum hold time should be there.
Period. How do you get your period?
It's setup plus hold time.
See, I'm asking about period, not. So this thing is there, right? The duration of your flip-flop that's going to hold. That's your period. In between this, everything happens. Okay. Fine. We'll move to the next questions. Okay. So what do you mean by slack phi?
Sir. Slack. Delay between. I'm not sure. Yeah.
Like slack high is a situation where like we will be expecting a 0 as our input, but we will be incurring a 1 at that input or output. Like it's basically an error. Like we will be expecting 0, we will be getting 1. Like there is also slack 0 also situation.
So what do you mean by skew then?
Skew is like unexpected toggling in the circuit. Like
So
it can be 1 to 0, 0 to 1, like nothing particular, but slack 0, high and 1 is something that we will be expecting the high, but it will be giving us 0.
Trisha, what do you mean by a clock?
Clock.
Hmm.
Clock is a signal.
Define clock.
Clock is a signal which is used to synchronize the operation between various in circuit. Which is used to synchronize the operation.
Define. I'm asking you to define a clock.
Clock a
Sai.
signal.
Sorry. Yeah. Continue, Trisha.
Clock is a signal. Clock is a signal. Uh, uh, it is basically used to synchronize the operation between various elements in circuit.
Then why do you give a clock to a particular chip? Why does a chip has a clock input? If it is going to synchronize the circuit, then why do you need a clock input for the circuit? If you have a clock internally, why do you need an external clock? I'm just asking you to define clock. Don't go with respect to any flip flops, any circuit. Just define a clock.
Clock provides time. Gives a timing constraint. It helps us to measure the time.
Not with respect to time, I'm asking. I'm just asking you to define a clock. Just define it for what do you know? Just define a clock. What do you know about the clock? You just define it. Like, what do you mean by a clock?
Is an input signal which is used to provide a reference to various operators.
Clock is a signal which toggles continuously. It is useful for the useful for the data transmission, means speed. It is at the speed of the circuit.
Came close to the answer and you went far away. Naina.
Yeah, it's a signal which oscillates between value 0 and 1. This oscillations depends on the frequency of the clock signal, how fast it should be toggled.
See, have a sine wave which oscillate between +5 and -5. Now, what do you call this?
It's just a signal.
Okay, signal. So, sine wave oscillating between +5 and -5 volt is a signal.
Yeah.
Clock is a signal which oscillates between 1 and 0.
Yeah.
Sure about that?
Yeah, clock is a signal which toggles between 1 and 0.
Trisha, you got any idea from this?
Clock is a signal which oscillates between high value and low value, and it is quite.
Shiva.
Hello?
Yeah. Any chance? Second chance for you? Any answers again?
It will be there from the starting at the end to the end of the simulation.
How can you say that you have an end for the clock, man?
No, means not end, means till now, means we will off the circuit.
See,
It continuously toggles.
you have a clock, right?
Yes.
So clock is nothing but a signal that oscillates uniformly, right?
Right.
Okay, it oscillates uniformly. Clock is signal that oscillates uniformly, continuously.
Okay.
Uniformly in the range of higher range to lower range. You can have your amplitude anything, +8 to -8, you can oscillate your signal. Okay, continuously means it will be oscillating continuously. Whatever the signal that is oscillating continuously uniformly within the range is a signal, a clock signal. That's a clock. Okay, we can use sine wave, square wave, ramp, everything. Everything is a clock which is oscillating continuously. That's a clock. Understood? So,
Okay,
what do you mean by yeah?
I have a question. Sorry to interrupt.
Yeah.
Like I don't know, like we have only used in circuit the clock which oscillates between 1 and 0. Like, is there any circuits like where we can use more than one also? Like, I'm just asking for the information.
Have you tried doing this circuit of parallel RCR R2 R2 or ladder network in analog analog labs? R2 or ladder networks. You have a resistor. You have another resistor like this,
Yeah, yeah,
right?
yeah,
And have you used op amps?
yeah. Okay.
Okay, you'll for op amps and all of these when you're trying to do anything with these things, you'll provide a sine wave input, right?
Yeah.
Analog. So you have sine wave inputs, you have
Mm.
positive and negative signs. So what will be your positive amplitude and negative amplitude?
Oh yeah, 4
From
over
zero you'll
signs.
have five.
Okay.
From
Yeah.
0 to you will have -5.
Mm.
So
Mm.
if you have to consider one cycle means from where to where you'll consider?
Yeah, like
From zero line to positive height
uh,
and again from lower to this. So this
yeah.
one cycle you call it as a period. So if
Yes.
those periods repeats
Mm.
repeatedly, what do you
Mm.
call them as?
Yeah, clock. That is also clock. Okay.
Okay. Yeah. Mm. Trisha, for you, what do you mean by fan out?
Fan out means when a branch divides into many branches, we call it as a fan out.
You call it as a fan out. Sai, what do you
From
mean
Yes.
by fan out?
Fan out means one signal coming from any gate or any flip flop which is connected to the multiple inputs. Multiple inputs means to multiple devices as an input.
Hmm.
Same signal
Okay.
that multiple outputs are called as fan out.
You can say Dmux as a fan out then.
No. So in Dmux, different values, different inputs will come, right? Fan out means same input will go to means same output from the past logic will go to different means devices. Or
So you call that as a fan out.
yes,
What do you mean by drive strength then?
drive strength means we can connect only not we can't connect as many as devices to the fan out, right? It has to be.
I know.
Basically, fan out is like maximum number of outputs which can be connected to an input. Like that only that number of outputs can be handled by that particular signal. That is fan out. Drive strength is something like how much strength a particular signal is needed to drive any output. Like can be
I'm
single or
asking drive strength with respect to a gate or a circuit or a device.
okay, like minimum some voltage need to be there like, to drive the signals from input to output. That will be drive strength.
Fine. Okay. What do you mean by rise time, Naina?
Okay, rise time is the minimum time from it to reach from uh, some to up to 90% from. I don't know the basic from, like it is the minimum reaching time from 60 to 90%, I guess.
Trisha.
rise time is the minimum amount of time which input takes to rise from 10% to 90% of the value.
Yeah.
It's only with respect to input.
No. Fall time also.
Sorry, it is with respect to the output.
Only output.
Yeah, only output. Because after the changing of the input, the time is the minimum amount of time taken to reach from 10% to 90% of.
What? 10%, 90% of what?
Input.
of the input value.
And I have earphones.
Sorry?
I have earphones. I can hear even a minute voice of yours. You helping her and everything.
Okay, sir.
Let it be kind of a little bit towards a formal interview, then completely a mock. Okay. Let her try, because if you get that feeling of not answering, at least you will revise those topics later. So if you help now, she might leave the topic in revision.
Yeah, sorry. It's not intention to help her. Like I just murmured, but it losing. Okay, sorry.
Continue. Actually, the thing is, you are. Sorry, you are lagging a lot, I guess, Trisha. Yeah, continue now. What do you mean by rise time? Your answer?
Yeah, it's a minimum amount of time which a device takes to reach from 10% to 90% of the input value.
Sai.
It's the time taking for any signal from going from 0 to 1.
0 to 1.
Yes.
Any answer to be revised, or one more chance for you all? Naina.
Yeah, I believe that rise time is it's a minimum time required to raise the signal from 10% to 90% of the input signal.
Trisha.
Let's see.
Sai.
It's the time required by signals going from lower level to the higher level of the value.
No. Yeah. Your last chance, Trisha.
It's a minimum amount of time which a signal takes to reach from 10% to 90% of the maximum value.
That's it?
Yeah.
You repeat again?
It's the minimum amount of time which a signal takes to reach from 10% to 90% of the maximum value.
Okay, that's good. That's the right answer. That's the right answer. Okay, fine. I'm going to give you all a question related to something with the clock. If I have a 250 megahertz of frequency of a clock, what would be my one time period? One period. What would be the time period of one cycle?
1 by frequency.
1 by 250 megahertz.
Need to do that.
Yeah, that's why I gave you this question.
Is it megahertz?
Megahertz. For everyone. Whoever knows the answer can let me know.
Forty nanoseconds.
40 nanoseconds.
I guess it's 4 nanos.
20 nanoseconds? 50 megahertz, right?
250. 250.
250. Okay. 4 nanosecond.
Yeah, now answer me. Sai, what's your answer?
4 nanosecond.
4 nanoseconds. Nayana,
40 nanoseconds.
Trisha.
4 nanoseconds.
Nayana, you're wrong. Answer is 4 nanoseconds.
Okay.
Okay. Have to be very perfect in these things. So, question for Sai. Why are NAND and NOR called as universal gates?
Because using those two gates, you can means create or build remaining all gates and not or X not. So we are
So with how many gates can you create a XOR using a NAND?
XOR using an AND. 4 gates.
4 gates. XOR using a NAND.
4.
Risha,
4 gates.
Naina.
4 gates. 4 gates.
Okay. Fine. Trisha, what do you mean by MUX?
Mux is a device which is used to select one input, one output from many inputs.
One output from many inputs.
Yeah, it channels one output out of many. It channels one input to the output out of many inputs using a select line.
Okay. So if I have to design a 4:1 MUX, how many select lines would I have?
We need 2 select lines.
2 select lines. Okay. If I have to design 8:1,
3 select lines.
so how do you say that you need so much select lines for so much of inputs?
Because we need 2 to the power n number of for 2 to the power n number of we need n select lines.
So next question to Sai. So what's the difference between an MUX and an encoder?
In multiplexer, we'll get the output based on the input and the select and the value at the input based on the select lines selecting. In case of encoder, one second. I forgot. Sorry.
Nayana. I can't hear you, Nayana. You're on mute.
In MUX, we have only one output, but in encoder, we will be having like 2 to the power of n input for the n output. So, like here, we are converting like binary into decimal numbers into binary. Like we are converting human understandable code into machine understanding code using encoder. But in MUX, we are just selecting one of many inputs using
So,
the select line.
so you said that you are going to convert human understandable code to machine understandable code in encoders.
Yeah.
So you can't read the outputs of encoders?
Yeah, we can read, like we have known with the binary numbers, like that will be fed with the computers and all, but it will be converted into binary. We can read
Okay,
that.
I'll ask a different question right now to the other two. What is the input that's going to be fed to the computers? Which language of input would be fed to the
Binary.
computer? Binary, sure.
Yes.
Both of you?
Yeah.
I'm shocked. What's your answer, Naina? What's the input that you are going to be feeding to your
Yeah, like one
language.
with zeros.
Call it as a language. Binary is not a language.
Okay, it's assembly language.
Binary is a number system.
Machine language.
Machine.
You are going very far because machine language was not there before 150, 200 years ago. It's a newer trend right now. And machine language has no connection with the inputs of computer.
From keyboard keys and
Yeah, man, you are going to press a key. You are going to
Yes.
press A. And
A.
how does your computer recognize that you have pressed A only? And how does it show that A on your screen?
It process as ASCII value. It process A as from
Hexadecimal.
physical value to
ASCII
the
value. So what do you mean by ASCII value? What is ASCII value?
computer understandable thing.
So what is ASCII value?
It's an American standard code. Codes are for the numbers from 0 to 15.
So what does it do?
Yeah, like from 0 to 9, it has its own unique code for each number. Like for A, 11 is. Sorry, can you?
ASCII is a language. Okay, when you press A, it will arrange the binary numbers in such a way that it defines a value in such numbers. Okay, that's ASCII language. We based on that ASCII language or ASCII language, your computer will take the inputs. Okay. You said that binary as an input. To brush up the skills. Fine, we'll move to the next question. Trisha, what do you mean by the counters?
Counters are the circuits which are used to count the number of clock cycles.
Only clock cycles? Then what do you mean?
No.
What happens with the asynchronous counters?
Not only clock cycles, we can count a particular segment, number of times the edges.
Naina.
Like we have two types of counters, synchronous and asynchronous counters. Counting is that like it does with the it particularly counts the number of numbers, like from up counter, down counter we have, and also we have different sequences also we have.
Define counter.
Okay, basically counter is a sequential circuit with the it counts with the clock cycle.
What does it count?
It counts the numbers.
Numbers? Sai.
Counter is a storing device which can it's storing device in the sense it can store right where they're from clock to clock, or that means it gives the it counts counter is a counter. It counts from with respect to the number of bit 1 bit counter to count 0 and 1.
Counter
basically counts.
That's correct. What does it count?
Like there can be up sequence, down sequence. And
what do you call that, up sequence and down sequence?
Up counter, down counter.
You call, if If it is going from one position, one thing to another thing, there's going to happen something. What do you call that?
Transition.
Event,
Change.
bro. Event.
Event.
Event. Okay.
Counter is nothing but a counter counts number of events. That's it. A circuit that counts the number of events is a counter. You count right.
Yes.
Count
Yes.
an event from 0 to 1. It is happening. There's an event happening at there. So it counts 1, 2, 3, 4. Right. So what's the major difference between synchronous and asynchronous counter, Trisha?
In synchronous counter, all the flip-flops get a single clock, whereas in asynchronous counter, the flip-flops get a clock from the previous flip-flops.
Can you elaborate your answer clearly?
In synchronous counters, all the flip-flops or registers available in that counter get a single clock. Operates with respect to a single clock only. But in asynchronous counters, the clocks are different, and generally, flip-flop gets a clock signal from its previous flip-flop.
Can you modify her answer, Sai? Or can you form a new answer?
Synchronous counter is depends on the clock, and every clock at just all the states of the flip-flop gets changed. But in case of asynchronous counter, in case of 4-bit counter, entire 4 clock cycles required to.
How is it built, man? How is a synchronous flip-flop built? How is a asynchronous flip-flop?
Synchronous flip-flop clock is fed to all flip-flops, and for asynchronous flip-flop, clock is fed to the only first flip-flop, and for other flip-flops, the clock input, it depends on the previous output.
Anna, your chance. You have 2 answers. Give me the correct answer.
In synchronous counters, a single clock signal will be there to instantiate all the flip-flops at a time. Like all the flip-flop will be started working at a single time. But what happens in asynchronous is only first flip-flop will be fed with the clock, and after that, after getting the output from the first flip-flop, that output either Q or Q bar will be fed to the clock as a second input. It will be fed output or Q bar as a clock in the second.
That's enough. The thing is, in asynchronous, you will have single clock fed to all the fed as a clock input to all the flip-flops. But in asynchronous, you will have one clock that is being fed to the first flip-flop. You both said that clock will be fed to all the flip-flops, not the same clock. You have to mention that you are feeding the same clock input to all the flip-flops, right? Because based upon your single clock only, your all flip-flops operate. That's what you have to say with the synchronous. Okay. So I'll ask the other question to my itself. So is your a ring counter asynchronous or asynchronous counter? Sorry.
Okay, ring counter is asynchronous counter. Q will be fed again. Actually, what happens here, the output of the Q is again fed into the input for the first flip-flop. So it will be counting for n flip-flop, it will be counting n number of states. Again, it will be repeating the same.
Okay, now the question for Trisha. So how does your counter resets to 0? Any counter, ring, Johnson, anything. What happens at the last flip-flop, and or how does it resets to 0?
It can reset if we provide clear signal or.
No. I'm asking. Okay, I'll give you an example. You have a mod 10 counter. So if you have a mod 10 counter, How many
Sorry.
how many number of counts does your mod 10 counter count? How many counts it does count? From where to where?
From 0 to 9.
Okay. So what happens after 9?
After 9, it will reset to 0.
How? You have the whiteboard, you can explain by drawing, or if you can explain by words, it's up to you.
We provide the condition in our circuit that whenever it reaches the maximum value, uh, then it resets to 0.
Naina.
We will be having any sequence, like after completing that sequence, like we will be for example, mod 7 counter means it has to go after 7, it has to go to 6. After that we will be designing that after
How?
7. Yeah, like after 7, getting that output, we will be giving the input to all the flip flop as 0.
Is it a synchronous or asynchronous circuit if your mod 10 counter is it a synchronous or asynchronous circuit?
Synchronous counter.
Okay, synchronous counter, fine. So if it's a synchronous counter, what's the first criteria you are going to consider there? All the clocks will be fed by the same signal, same clock signal.
Yeah.
So if it is at 9,
Mm.
what happens after that?
Okay, if it is at 9,
9 means what will be the uh, binary number that will be present at the outputs? How many outputs does your mod 10 counter have usually?
mod 10 means we will be having 4 flip flops.
Okay.
Mod 9 is nothing but 1001.
Hmm.
Yeah, like we will be designing that 10. If we get 1001, all the then again it should start from 0. Like input will be reset to 000.
If you provide input to 000, what will be your output?
It start counting from again from 000.
How? You are saying that after 1001, you're going to start from 000 again. How? How does it resets to 9 to 1? It can reset from 8 to 9, right? How does it resets from 9 to 0? Trisha, Sai, any of you can answer. Yeah,
I
yeah.
can answer, sir. By taking the condition is like 1001, right? So taking each, if one means we'll take an AND gate and feed it to all the input. And in NAND gate input to the NAND gate is for flip flop getting 1, we'll get directly connect to it, and getting 0, we use an inverter and connect to the NAND gate. So all ones means we'll get 0 as output.
By which flip flop do you design your mod 10 counter?
D flip flop.
A day flip flop. Trisha.
Yes.
D flip flop we can use.
Naina.
Yeah, preferably flip-flop. We can also design it using T flip-flop and JK flip-flop also, but D flip-flop will give the result in less complex circuit.
Okay. So how does it happen now? Now tell me the connections, Trisha. If you have a flip flop, okay. If you have a flip flop, how is it connected? Like for example, I don't know. Just give me a second. Oh. Sorry. Yeah. Naina, it's to you. You said that you are going to design your counter using D flip-flop, right?
Yes.
Who else said D flip-flop?
I also said flip-flop.
Okay, fine. Now tell me how you are going to connect your D flip-flop.
Clock is connected to all the flip-flops,
Correct.
single clock, and
Okay.
input is given to the first flip-flop, and output of this first flip-flop is given to the second flip-flop. In that fashion, we will connect all the flip-flops, and the output of each flip-flop is taken outside, four bits. On that, we will see the output counting.
Outputs of the repeat the thing.
Output of the each flip-flop, we took those outputs. Those are 4 bits, and we will see the output counting values from 0 to 10, or 0 to 9, depending on the model.
I'll give one more hint. What do you call a Morton counter by the other name? What does a Morton counter called as by other name?
Modulo 10 counter.
What do you call the other? What's the other name for Morton counter?
No idea.
Trisha, Naina.
No idea.
This counter is called as decade counter.
Yeah.
Any hints? No, I given the hint. Any ideas from this hint? How do you design a decade counter? Why is it called a decade counter?
Decade is represents 10.
10.
So it is called as decade counter.
Okay. How is it designed?
Yeah, like in synchronous counter, if you are designing modulus 10 means like 10 is nothing but 1010. So we will be taking this output from all the flip-flop. The Q will be taken out, and we will be connecting it to a NAND gate. That NAND gate output will be connected to the reset. We will be connecting.
Not NAND gate. We'll have something other. Okay, fine. Okay, and not. Oh, fine. Yeah, correct. You're going correct. Continue.
Okay, we will like that NAND gate will be designed in such that if we get it input as 1010, that will be automatically gives S to 1, so that reset will be active, so that all the flip flop will become 0.
Right. Okay. Fine. I think this is okay. I have few more questions. What do you mean by a cell delay, Trisha?
Cell delay is a delay which a register takes after getting the clock cycle. Register takes to reflect the output means after changing of the input.
Cell delay, I'm asking.
It's a propagation delay between input and output.
Of what?
Inside a cell or a
Which
register.
cell?
Flip-flop.
Fine. Okay. Fine. I think this is enough for today. Yeah. Fine. We'll wind up it here. Okay. Yeah, I'll give some feedbacks. Hope you all follow it and improve. Trisha, you have to work a lot on basics. Okay. You have to. You see, the thing is, you have studied, but you don't know where to pick those answers. You know the answers, but you lag somewhere, or you have some misconceptions where you have understood in a different way, so you are not able to get to the interviewer's question or get to the questions, and you can't answer them properly with confidence. That's what you're lagging. So what I suggest is that try to start from basics of digital, go with everything, understand, try to work a lot on waveforms. See, once when you start with the waveforms, try to implement the logic of particular cell, flip-flop, everything on the waveform. So the main thing about all three are DV, right?
Yes.
Yeah, you have to work a lot on waveforms, as I know. You have to work a lot on waveforms. See, every morning when you sit to work, you'll pass something from the cell and you get something from the output as some output. So you have to analyze the waveforms. You have to analyze your clock, input, output, everything. So you have to work a lot on waveform part. So start doing that. Try to solve some any gate papers, something, all of these in digital electronics. So that will help a lot. I'm saying this to everyone. And for you, Naina, you feel overconfident about some topics, and on in the flow you say a lot, and you say everything wrong in the flow. Sometimes you are confident on few topics and you say it very clearly. That's good. But on some other topics or most of the left out topics, apart from which you are not confident, you say them in a confusion state, or you say them in a overconfident state and say it in a wrong way. So you also have to go through all the basics of digital and start with that. So I suggest you all to start with the number systems first: decimal, binary, octal, hexadecimal, everything, conversions, additions, everything with that. Then go with the gates, go with the basic definitions, because whenever you're going to company, no one is going to ask you to, or design you ask you to design a full ladder, full subtractor, or no one is going to ask you to design a ring counter, because the interviewer want to take the interview for just 1 hour per person. So you don't want to give you 30 minutes to write or 20 15 minutes to write a ring counter. They won't ask you to design. That's very rare cases, and he doesn't only stick to digital electronics. He will jump to your DV also. So when he wants to jump to DV, you have to know certain basic questions or basic concepts about digital electronics that will relate you in DV. Okay, so if you are going to DV, you have to know some things that you are going to use in your DV. So those questions will be thrown at you, like this: cell delay, propagation delay, rise time, fall time, slacks, skew, flip flops. What is the difference between flip flop and latch, gates, everything. So, and what do I mean by a gate? So by definition, you will understand what's that's going to happen with that particular thing. If you're considering a block, or if you're considering block that has an AND gate, if you know by definition what's an AND gate is going to do, or by logic what's an AND gate is going to do, you'll be able to solve it. So that's what they will do. They'll dig you your knowledge completely in the basics only, very basics. I'm saying very basics. The first chapter, second chapter, third chapter of your digital electronics is your main thing you have to focus. That's like a holy water. Once it's sprayed on you, you are going to be masters in your all the areas. Okay, so that's the one thing I'm going to say. And Sai, yeah, for you also,
Yes, sir.
the same thing. You have to work, and you know the answers, but yeah, you confuse. And yeah, before preparing anything, don't go too much advanced.
Okay.
Start everything from the basics. Be perfect in basics, then you will be able to crack anything. Okay, that's one thing I'm going to tell this thing to all three of you. And be focused on analog also. Most of all, CMOS theory. CMOS theory is going to be one of the important topic for you. And try to focus or read some articles on FinFET technologies also. There's going to be some questions on the FinFET technologies also. Hold on for a second. Yeah, FinFET technologies also and CMOS also. Be strong in this, and yeah, try to understand the questions being thrown at you. because there will always be a hidden answer in your question, or a hidden tricky question being asked to you. Try to decode that. See, interview doesn't want to ask 55 questions. He wants to ask you 10 questions for which you need to be answering in such a way that you should show your interview that you know the basics by answering those questions. Okay, someone said that rise time is time taken from 10% to 90% of input signal. You can have rise time even in a clock signal, input signal, output signal, everything. A signal which has it takes from 0% to 90% is a rise time of that signal. You can have it in sine wave, square wave, ramp, everything. Be clear with the signals and all. What's this signal? What's the like this? Be specific. See, if you say this in a signal, any signal that takes time from 0%, sorry, 10% to 90% of its maximum value is a rise time. That's enough. That defines that you know completely about this signal, you know completely about rise time, fall time, that all thing. Okay, be clear with your answers. If you and the other thing is when you are saying a sentence, complete it. Rise time. This is rise time, or this conclude it. So once when you conclude it, they'll understand. Okay, this is the answer. If you and sometimes you'll be saying like 10% to 90%, and if the interviewer doesn't hear your last words, he doesn't feel what you are saying is a concluded answer. Okay, yeah, there are a lot of other things. Yeah, you all have to figure out the way of answering the questions. You will get it. Try to take up more and more mock interviews, or try to go through the interviews attended by others, like in VLSI For All YouTube channel you can see. So from there you can get most of the questions. Just take a white sheet and note down all the questions which you are seeing on YouTube, on VLSI For All, any others. Note it down. Try to prepare for those questions and try to give in your way of answering, like even your way, but let it be connected to the topic and the answer. Try to give it in your way. That will help the interviewer understand your unique way of answering, or your unique way of understanding the concepts. All the thing the interviewer checks is that how much you have understood your concepts. Okay, that's what. It doesn't care about degrees, CGPAs, projects. Yeah, you do care about the projects until and unless you have the knowledge about it. If not, if you don't have any knowledge about your degree projects or engineering masters or engineering projects, it doesn't care. Or if it doesn't relate to your what you are going to work, he doesn't care. So all he cares about is your knowledge. Be focused and preparing about it. Okay. So yeah, digital, CMOS theory, analog theory, go with the latest FinFET technologies. Try to understand or go with the news of recent updates on semiconductor industries, because those will, you can take those things and answer, because they'll be asking you one question: why do you want to get into VLSI industry? Be prepared for these questions, okay? And they will ask you what is the latest nanometer technology that's running in the industry. There you might expect these questions. Any idea what's the latest nanometer technology that's running in the industry?
3 nanometer.
3 nanometer. By whom? Where?
TSMC.
TSMC is a fab. I'm asking who designed the 3 nanometer technology.
Samsung.
IBM.
Sorry?
IBM.
Samsung.
Every year, the shrink in nanometer technology is happening. That one company that releases in September. Which one is? Your Apple. Right? All of your Apple's A13 bionic chip, A14 bionic chip, all of these are with the shrinking technology. They started with C7 nanometer, 5 nanometer, 3 nanometer. These all updates you need to know. Just go through it. You don't need to sit and study with the book. Just go through the blogs. Just go through the updates that's going on. TSMC is a fab that manufactures these these chips, 3 nanometer chips, 5 nanometer chips. They are not going to design it. You are going to give a GDS2 file that's going to TSMC fab unit. There it's going to be manufactured. They are not going to design your 3 nanometer chip. Okay, fine. That's it for today, because if I take more time, it won't be fine. Keep preparing, focus on digital everything, and do well. Okay. If you have any questions, throw it out. If not, then we'll end the session.
Sir, I have a question.
Yeah.
As you said, to cope up with the latest news of the semiconductor, like, is there any particular blog or website you follow? Or
See, I'll tell you one thing. Are you which mobile device are you using? Like, I'm
which
not asking about the brand. I'm asking about the OS, Android
which
or iOS.
yeah, Android phone.
Android. Okay. You have a tab, right? You have a tab. If you unlock, if you scroll left side, you'll have this thing, right? If you do this thing, you'll get your news feed, right?
Yes.
Once or twice you try to search about the latest technology about this. Every day morning or every day evening, you will get news about those whatever your latest technology or latest news about the semiconductor. Once or twice, if you search, you'll get it repeatedly. You don't need to go through any particular website. You will get continuously, repeatedly. So every time, so you just press on that, read it, close it. Again, once when you refresh it, you'll get another update. Just that's enough for you.
In real interview, how much time they will take for one round?
Sorry.
In interviews, how many hours they will take, means 1 hour or it will be more than
Depends.
that?
It depends, because sometimes it goes to long hours. Like sometimes they might take you to 3 hours.
Okay.
Sometimes it goes 2 hours. Yeah, it depends, because if it's only a one round interview, just one technical round interview, and then the next round is for HR, then they'll take you for 2 hours, 1.5 hours. If it is multiple rounds, then that will be like 30-40 minutes one round. Depends on how you answer. If you keep on answering in a particular way, or if they are expected way, they will keep on taking. If you make mistakes, or if you give a bluffing answers, they'll stop, because they don't want to waste much of their time in taking an interview for you, because they are looking for a particular or a good candidate, so knowledgeable candidate. They will choose the other candidate than you, and they'll stop taking spending much time for you, because they'll try to ask you more questions. But if you are following the same path of answering or bluffing from the first to last, they'll understand after 4 to 5 questions. They'll stop asking you the questions, and they'll choose the other candidate to interview.
One more thing, like how many projects are good number in resume?
There's nothing about the number. See,
Okay.
if you have one project in your BE,
Okay.
that's more than enough. But you need to have the knowledge about your project.
Okay.
You see, everyone does their project, and everyone will be doing mostly in embedded IoT or automations. So
Yes.
for sure, the interviewer will be having the knowledge about these things, and he will try to ask you a question regarding your project with whatever the knowledge he has.
Yes.
With
Means
your knowledge, you have to enlighten him about your project. Only then he will be impressed, or he'll be convinced about your project. If not, then he'll assume you have not done anything in your project, just followed the paths of your seniors, or just followed the paths of someone who has someone others, or by your guide, and you have done your project.
means my question is like resume shortlisting will happen, right? So what the basic thing they will look into the resume?
It should not be similar to the others' resume. No one shortlist your resume by looking like this.
Okay.
It will go through a software. They'll ask you to mail nowadays.
Yes. Yes.
Those will go through a software shortlisters, because your resume format needs to be similar, but not the content. Your resume and Trisha's resume content and format are same, then both of your resume will be rejected, because it looks similar. Your resume needs to be unique. It needs to match the keywords of the job description that's being posted. For example, if they have posted DV, for example, I'll give you a PD. If they are asking, if the keywords are mentioned as timing closure, STA, a few other questions, like a few other keywords like placement, floor plan, synthesis, macros, standard cells, these things. If these things are there in my resume, if I have mentioned anywhere as worked on STA or timing closure of 40 nanometer technology, something and all, then they will take my resume. That resume will be shortlisted because the keywords are matching to the job role, right?
Okay.
You have to focus on these things. Keywords, about keywords and resume thing. Second thing is your resume format and data, whatever is there in your resume need like it should be genuine, should not be copied, or your resume doesn't uh, need to be same with like others.
Okay. Thank you.
Okay. Anything from you, Trisha?
No, sir. No, sir.
Fine then. Okay. Yeah, one more thing. I'll give one more small advice. Every time when you're sitting into an interview, keep your camera in a straight angle. Don't go like this. Like Shiva, you are there. Okay, always sit straight like this. Make sure that you are at least visible to this extent. Okay, and always make sure that you are let the interviewer know your hands are visible to them, because sometimes what happens if your hands are not visible, they might see that you are cheating something and all. And always always have this clear view. Don't like let the camera not be like this and you're looking from this angle, or let it not be like this one. Make sure that your angle is clear, and let your room be well lit so that it has enough or sufficient lighting so that you are visible clearly. And yeah, if not, then use these kind of backgrounds. If your background is not good, use these kind of backgrounds which I have used. You can get it directly on Zoom. You can use
Okay.
go here and choose background something. In more option, you can choose the backgrounds and all. Apply visual effect and all, and you can change your visuals. Okay, that will look decent than sitting somewhere else. And if the background is not so okay, then okay, make sure that you sit in a well lit place so that the interviewer sees your face clearly. Okay.
Okay.
And also, while answering, if you don't know anything, just say I don't know. Don't try to answer it. See, if you genuinely know the answer, and if you are missing some words or keywords, then try. If you don't know anything, but if you want to answer, then don't do that, because interviewer doesn't want you to be perfect in all the areas, but he just want you to answer properly. So if you miss or don't know 2-3, then 2-3 questions, then leave it. Okay,
Okay.
and answer the rest. Fine, that's okay. Prepare well. All the best. Thanks for joining. Okay, bye.